Hello and welcome to another Thinking Particles tutorial video. Let's do some iconic fluid splashes together, shall we? In this unscripted tutorial, I will show you how easy it is to create a rigid body dynamic setup that properly interacts with fluid. This tutorial video uses our yet-to-be-released SPH 7.3 solver. By the time this video is out, you will soon see a free upgrade to Thinking Particles available to all subscription users. This new solver offers many new innovations and fine-tuning, specifically in its surface tension behavior. I'm your host Edwin Brown, and let's do this now. Before we start setting up our visual effect, let's have a look at the scene first. The scene is made out of these ice cubes, which are, let me just show you, simple boxes with a noise modifier. Then we have this ground or floor object, which is a simple box as well. And then we have our glass here with a lathe modifier. So pretty simple basic objects, all created in 3D Studio Max. And now let's start with our visual effect setup. We are going to use Thinking Particles, and for that I'm going into the Particle System section, and I'll just choose Thinking Particles. It doesn't matter where we click or create our Thinking Particles system. It's just a helper that will store all our visual effects setup. So I'll just click the Thinking Particles helper here. To bring up the user interface, I'll just click the Properties button, and that will bring up my Thinking Particles user interface. And now we can start setting up our visual effect. So the first thing we need to think about is from what we have in the scene is our ice cubes, and we have our glass and floor. And later we want to have some interaction with fluid somehow. So those are the objects. So we need to somehow get these objects under control of Thinking Particles, our visual effect system. So we need to get these objects somehow into the system, into this setup of Thinking Particles so that we can use and interact with it. We introduced that, I think, in Thinking Particles 7, we have this presets button. You can create your own presets, save them on your own, so you can create an empty preset, and I'm going to use a basics preset we ship with every Thinking Particles, and I'm using the basic setup for bullet physics. So I just click the preset button and it creates all the minimum nodes you would need if you wanted to do a bullet physics rigid body simulation. And because this tutorial is about rigid body and fluid interactions, we will start with that. So it also created some interesting particle groups. So we can use the particle groups. I know I would not need, for example, the particle group non-gravity and field. I don't need that as well. The only thing I want is my gravity for rigid bodies, and as I said, we want to have some fluids as well. So I create a new particle group called fluid. And I think that's about it. I don't know if I would need the meshes. I'll just keep that for now. So the next thing is our create. This is where everything happens. We bring in all the objects or create all the objects we want to have in our visual effects setup. So what we are going to do now here is we are just selecting our object to particle, and we are going to pick our objects. I'm going to just pick, because I'm lazy, we could pick by list or name, but we are just picking those three. It's easy. Then I'm going to adjust all objects in here. I'll put the ice cubes in the rigid body. I want the object to particle, and I need the shape in Thinking Particles so we can do bullet physics interactions. The next thing that was already set up through the preset is what you need with bullet physics setups is you need to assign a rigid body parameter set. We do that by, for each particle we bring in, that's our ice cubes, we assign a rigid body parameter set. And the parameter set is a convex hull. We want them to be active, and all kinds of settings we want to adjust here. I might want, because I want them to bounce a little bit around the ice cubes when they hit something. So I'll give it a little bit of restitution value. I'll increase that. And also I want to have a little bit more friction. I know it's ice cubes, but let's give them a little bit of friction. And because we are here in right now tutorial land, we want to make this a little bit rough, so I'll increase the margin so that we can have faster simulation times by just going a little bit more rough in bigger time steps and so on. So I'll give it a little bit more margin for the collision, and that's probably all we need to do for bringing in our ice cubes. However, we need to be, because I said I wanted to create an interaction with a fluid, we need to think about when rigid body interact with fluids, do we want to have a real interaction like in the real world? So the fluid pushes away our rigid body, or even is our rigid body able to float on the surface or even buoyant? So does it rise up and all these kind of things? So that means we need to bring in or assign a standard value like mass, for example. So I'm going to choose a mass operator and assign a mass to these particles. So what I'm going to do is assign just a mass. And because we are interacting with fluid particles, we need to be aware that each individual particle will have its own mass. So I'm just starting with a value of 500. So each particle usually by default will have one. So if we have 500 particles pushing against this ice cube, it will start floating and so on. We have to do some trial and error and find out what we want to have. The next thing I want to do is I want to have some initial velocity so that we don't have to wait until the gravity kicks in. So I'll just get a velocity node. I just pressed the tab key and typed in velocity. So now I'll assign a velocity to these particles as well. And the velocity should point down. So I'll just make this -1. And let's give it a nice down force. So now we have all the setup we wanted. We have our rigid body. Let's have a look at the rigid body. The solver is already selected because I used the preset, remember? So I don't have to care about that. Usually you would need to care about which solver you want to use. You can have multiple physics solvers that are independent, but right now that's all fine. That's what we want. So now we need to make sure, one thing we forgot when we brought in the particles, we have them in the rigid body and we need to check the rigid body are in the gravity group. Let's just, for the purpose to know that we didn't do any mistake or error, the gravity force is including all the subgroups. That's fine. We want gravity on the rigid bodies and the fluid itself. And we have the force pointing down. So that's our setup we have here. And because we are here in a millimeter space and we want to have a certain look, I'm just going to have that at 98 point something millimeters. So that's my force. And let's have a look if this somehow makes sense. I'll just make this full screen. Let me just move the interface a little bit out of here. And let's have a look. And we can see particles are falling down and we see them duplicated because we still have our original meshes in here. So I'll just hide the original 3D Studio Max meshes and now we just have our thinking particles falling down with their own mesh. So that is what we have achieved right now. The next thing we might want to do is actually have the interaction with our glass. And we can do that in our simulation setup. So when we are inside of our simulation setup, we would just go to our bullet physics. And what we want to have is a floor node. It's not really a floor, it's a glass in that sense, but it doesn't matter. Because we're lazy, I'm just pressing tab again, type in node, and I'll feed in the node into the floor node. So now I'll just double click the name to collapse that. I'll pick my glass. That was the line 01 as we remember. So I picked the glass. What we need to make sure is we have a mesh collision, because if we use any other procedural collision, the cubes won't fall in. So we need to have a mesh collision with our glass, which is fine right now because we use the cubes with a convex hull. And the same deal here. I want the cubes a little bit to bounce around. And also the margin for collision should be 1 millimeter. And that's practically it. There is nothing else we need to adjust. Bullet physics is pretty good and robust here. And we can just have a look right now. Let me just move that out and away. And we'll have already the collision here. Let me just move my viewport maybe a little bit like that. And let's do that again. So we have the ice cubes in here bouncing around exactly as we want. So that was an easy, simple setup. However, there's one thing I did not tell you about. Let's have a look in the master dynamic setup. In the master dynamic setup, I can see we have 0 subsamples right now, which is fine for now. We didn't see any error. Let me just make sure that we actually did not see any error. But usually 0 subsamples, no, we see it's diving way into the glass. So that's not acceptable. So usually you fix that very easy by increasing the subsamples to 1 or 2. For the sake of having a good collision detection, we want to have it like that. And there we go. That is exactly what we want. And the good thing about it is the more subsamples we have, the more we get to the real thing. So that's done. We have our subsamples. Our bullet collision is working. And now let's do some fluid or liquid. I'm going back to my create dynamic set, and I'm going to use a water level. That's the easiest and fastest way to set up or create a fluid inside of our glass. So how is that working? It's actually pretty simple, and it's so easy and fast to set up. Let me just move that out of the way so that we can actually create our water plane. So the first thing for the water level you need to do is you need to have an object that acts as your water level. And I'm going to just create a simple plane. And this plane will actually act as my water level. So wherever this plane is, we will have the water. Let me just bring that back in. Here's our water level node. And I'm going to set up our node by adding the plane, which is our water level object. And our ground object, or where the water should land, is our glass. So I pick the line 01, that's our drinking glass. So the rest we can leave nearly at the defaults. When you first create, you're in test mode. And you already see here, we have these lines going down. That's my particles it will create. Let me just go here to wireframe mode. So this is the volume that will be filled with particles. So very simple. There's nothing easier, nothing faster to fill an object or a landscape with water or fluid. So The grid size is my distance between the particles, and for this tutorial I'm going to use 2.8 millimeters, and it tells you how many particles it will create. So I'll turn off the show, and we're going from test to generate mode. So now if I restart the simulation, we will see the particles. The only thing we need to make sure is that we create these particles in the fluid group. So I'll want these fluid particles to land in the fluid group. That's another important thing we need to adjust here and make sure this is working. And we leave everything else at default. The mass is default, everything else is default. So now if I restart the simulation back and forth, we can see our particles in here. Let me just change. I'll just click on Master Dynamic here and change the display to dots. Now we have the dots here, and we can see here are our particles. So now we filled up our volume. We have our water level with these particles. Let's continue and create. Let me just go in here in our simulation group. Let's create now the next thing we need to do. So for the fluid solver, what we want to do is start with a flow group. So I'll press tab again, type in flow, and we'll start with our flow group. Keep in mind, the order is important. We want to have the flow group on the top. So let me just visualize it in here. This doesn't matter, but we can have, let me just move that up here. Our flow group on the top. The next thing we want to have probably is a boundary, a flow boundary, because we want to have the boundary, the fluid to interact with the glass and with the ice cubes. So what we do now is have a flow boundary, and probably if we think about it, we want to have a flow boundary with the rigid bodies, with the ice cubes, and we want to have a flow boundary with our glass. So I'll add a second flow boundary. And then the next one is another flow boundary, probably for our floor. I'm spreading those out to 3 boundaries right now, but I don't know if we need that, but let's separate those and we have more control over every individual boundary. And the last thing we need to do is our fluid solver. So I'll press tab again and I'll grab our flow solver. So it is important that the flow solver is the last node in the hierarchy. If we put the flow solver before, it won't work. So flow solver is always the last here. So as I mentioned, let me just bring in the first boundary, and that's our rigid body objects. That's the ice cubes. So I'll go with the group, particle group, and I'll feed in the rigid body dynamics. And for that, I want to have intersect with voxels because we're interacting with volumes, our liquid and meshes. So I'll use both. And I want to make sure we have a void inside, and I want a proper resolution for our objects and probably just a tiny little bit of a margin. The great thing is about voxels, they are very robust with collision detection and boundaries. So that's all I'm setting up here right now. So that's my first boundary, the ice cubes falling down so they interact with my fluid. The next boundary would be my glass. We talked about it. So let me just bring in the glass object. Now I'm picking the glass because we did not bring in the glass as a rigid body. The glass is still a 3D Studio Max object. So I'll just pick that and say, okay, this is my glass and I don't want it to move or interact with anything. and I want to make sure we have that. So that should work just fine with the defaults. The last one is my floor. I'll pick the floor object. Let me just pick it here. And I have my floor object in here. And for the floor object, same deal. I'm not going to change anything. It's not movable. All done. So ray intersect, that's all fine. That's exactly what we want to do. And for my flow solver, when we're talking about fluids, I'll give it, just to be sure, 2 subsamples. So that should give me a pretty accurate simulation. The next thing I want to do is I want to hide, let me just go back. I want to hide my plane, my water level plane. Let me just hide that. Yes. So I hit the water level plane and now we just have our water level in here. The next thing is probably we need to set up our flow solver, and we do that by choosing the flow solver, which we do here. And we are going to use the fluids particle. And we are going to use a brand new solver. As I mentioned before in the introduction of this video, this is a new solver. You will soon have it. When this video is out, it will take a few more weeks maybe, and then you'll have this solver as well. We're preparing right now, in the middle of preparing an update. However, you can use all the other solvers as well. You will get similar results. However, this solver is especially useful in this case. Let's just have a look how everything looks like from the beginning if we work with default, so that we can get a feeling of what's going on. I think the best viewport for that is looking just right. I'll just move that out of the way. Right here for our boundary. And I was just going here into the boundary where we select the flow solver and make sure it's the flow solver. So now everything is working. So every node knows where to get the data. And let's redo this simulation again. Just reset the simulation and just play the simulation again. Okay, simulation starts and we see fluid collapses. So what we can see here is that our fluid totally compresses or collapses, and we don't want that for sure. So what we need to adjust now is some settings in our fluid solver so that we get a correct or believable result, so to say. So the first thing when fluids collapse is probably our smoothing radius is not really probably selected. Because what we want to do is that each of these fluid particles finds a neighbor so that it knows what it should do. If there's pressure, it needs to pass on the pressure and so on. So we need to increase the smoothing radius a little bit. The next thing, we need to decrease our density so that we have already a pressure. And I'll show you in a second how this should look like. Let me just go and adjust the other settings as well. So we want to have a decompress to fight against the gravity. We know that we have a gravity pushing down these particles, so we need to fight against the gravity. And our new solver is doing a much better job with surface tension now for fluids or liquids. And maybe I'll just increase a little bit the viscosity. And the rest, I think we can leave as is. Maybe we want to get a little bit more. That's now special for this new solver. A little bit more of acceleration limit so that the forces that are created are acting or reacting much, much faster. And also we want to make sure we have a little bit of friction so that this doesn't bounce or behave erratically. So a little bit of friction is physically accurate and real. So we just add that here. So those are the parameters you can play or will play around most. But as I said, let me now just reset the simulation so that we can see what we adjusted here or what we did here. So I'll just go one step back. And now if you see this kind of color, That's probably a very good starting point for our density and pressure. Let's have a look now how this looks right now. Fluid is expanding, ice cubes falling in. So that looks already pretty good. Ice cubes are floating, buoyancy, we have everything in here. However, maybe I want to increase just a tiny little bit the density. What that means is, maybe it was too much. We are looking for this nice dark bluish look so that we are close to collapsing and expanding. Now we have a nice interaction. So let's have a look now what our fluid is doing. So we can see the ice cubes are floating way too easy. So what I want to do now is just increase the mass of our ice cubes. So I'll just increase that to 2500. And let's have a look right now how these ice cubes look right now. And it's, I guess, much easier to visualize if we create a surface. So why not create a surface? Let me just rename this dynamic set to surface. And we are just looking for an open VDB shape that we want to assign to our particles. So let's assign this to the fluid particles. We want to give them a shape, and let's adjust this to something we want to have here. Maybe this. That looks good. And a smooth surface we want. And probably we want to have something like that for the visualization side, and a little bit of half bandwidth. So those parameters are just trial and error. So you'll find them very fast. The radius scale is based on, do the particles touch each other? Do you want to create a surface? And all this effects we want to see there. So now we have a surface. Let me just remove the dots there a little bit. Let's just zoom in a little bit more, something like that, and have a look what's going on. Ice cubes falling down, and nice sloshing around, displacement of fluid. That looks pretty good. So now if we get the feeling that our fluid is not bouncy or splashy enough, if we want to have more splashes, we would just go into our flow group, and then we would just pump in a little bit more of energy. So I'm going back to a 1.1. So that will give a much more energy into the system. And now let me just overdo it, and let's have another simulation going here with these settings. Okay, once again, ice cubes. The fluid is now reacting faster. And what you could see here really nice is when we increase the power, the springiness or splashiness in our fluid, it also gives more power towards the ice cubes. So probably I would want to increase the mass even more so that the ice cubes have more power to push around the fluid. So I'll increase the mass to 5000, and I guess we leave all the other settings as is for now, and let's just do another simulation pass so that you can see the only thing I change now is the mass. And once more falling down. Now nice bounce. So you can see they're heavier now, but still. So we could see on this ice cube, it's still too light. So that's more like foam or very light stuff. So I'll just give it some really power now. And let's have a look when we just change the mass of our ice cubes. With this mass, we should get a real nice bounce and pressure distribution in the fluid. And it looks like it. Okay, I love that one. So that's a really nice one. And once more, what it shows is it's up to you. You have all the power now to play around with the physics forces, with the effects, to adjust the look and feel you want to achieve. This is a very easy, powerful, fast setup for your thinking particles, interaction, rigid body, fluid dynamics, all in one go. I hope you enjoyed this tutorial. Thank you for watching this tutorial, and just as a reminder, there will be a 7.3 update coming soon that will introduce this new Fluid Solver SPH solver. Thanks again for watching this video.